Hello friends, good morning and welcome back in the second chapter of Basic Mechanical Engineering titled Property of the Steam. So today we are going to discuss topic 4, that is combined separating and throttling calorimeter. This is a QR code for the channel and channel name is AVM Tech Android. So in the last two videos we had discussed about the working of separating calorimeter with limitation, working of throttling calorimeter and their limitations. So now the very first question is why we have to go for a combined separating and throttling calorimeter. So the answer is mentioned here. In the separating calorimeter removes and measure some of the water in the wet steam, but it cannot remove all the moisture. Whereas if we talk about the throttling calorimeter, that measure dryness fraction accurately, but limitation is almost dry steam is necessary, means if the dryness fraction is more than 0.95, then and then we can go for a throttling calorimeter. So therefore for a wet steam, first we have to use the separating calorimeter. We have to remove most of the moisture and then you can say almost steam that has to enter into the throttling calorimeter to measure the dryness fraction accurately. This combination is called combined separating and throttling calorimeter. So in the exam the question may be there, what is the need to go for combined separating and throttling calorimeter, or you may ask explain with neat sketch about the working of combined separating and throttling calorimeter, plus chance will be that numerical will be asked. So we have to discuss all points and we have to discuss about now working of separating and throttling calorimeter. So if we talk about the construction part, as you can see, initial part is a separating calorimeter and the next part is a throttling calorimeter. So first is a separating calorimeter that receive the wet steam from the main steam. This is the main steam pipeline. So wet steam is entering here from the main steam pipeline. Perforated cup or buffet plate or deflector is provided so that droplet can set at bottom, and the separated water that will be collected and measured, and that is known as the M2 at later stage we will discuss. Now in case of the throttling calorimeter, what you can see is almost dry saturated steam. The almost dry saturated steam is entering into the throttling calorimeter. It will pass through the throttle or orifice or a valve. All of a sudden pressure will decrease. It is isenthalpic process. H1 equals to H2, or you can say enthalpy before throttling is equals to enthalpy after throttling. Steam becomes superheated, its temperature and pressure that will be measured, and we can calculate what is the value of X in that case. So again we will discuss in detail with help of a neat sketch. So friend, you can see here this is the main steam pipeline. So when the steam is allowed through the stop valve, ms plus mw, that is mass of the steam, plus mass of water, that is total mass, that is entering into the separating calorimeter. It will strike to this perforated cup or baffle and its direction will be changed, that is direction will be in upward direction. So the steam that will be reflected in upward direction, but the water particles which are heavier one that cannot be lifted in upward direction, that will be collected at the bottom. When we will operate this valve, that will be collected and we can measure what is the amount of water separated from the separating calorimeter. Now what happens is almost dry steam that is entering into the throttling calorimeter. So we know what is the pressure before throttle, what is the pressure after throttle. and when this throttle valve will be operated, this steam enter into the throttling calorimeter. So what is known to us is here enthalpy before throttling and enthalpy after throttling remains same. Due to this throttling process, all of a sudden drop in the pressure will be observed, and corresponding to that drop pressure, the saturation temperature will be decreased. Temporarily the steam become a superheated steam, and as it is isenthalpic process, we have to write H1 equals to H2, and we have to find out what is the dryness fraction. So what we know, the working of separating calorimeter, and what we know, the working of throttling calorimeter, we have to combine these two, and we have to do this exercise to find out what is the final X value. So same thing is mentioned here, step by step working, steam sampling, partial separation and throttling. Here just you can go through this slide, you can understand what we had discussed. Same thing is mentioned here. Again we have to measure what is the pressure P2, temperature T2, and how to calculate the steam dryness fraction. What we had discussed, same thing is mentioned again in this slide. Just you go through the slide, you can understand what we had discussed. Same thing is mentioned here. So now we have to talk about the calculation part. So in the calculation part, what you can see, M1, that is a mass of almost dry steam leaving the separating calorimeter. So M1, that is a mass that is entered into the throttling calorimeter. M2, that is a mass of water separated in the separating calorimeter. So here M2, that is a mass collected here, M2. X1, that is the dryness fraction of the steam leaving the separating calorimeter. So what is the mass M1 entering? It is entering with the dryness fraction X1, and X, that is the value of dryness fraction of the original steam which is entering into the sample. So X is the dryness fraction of this steam which is entering from the main steam main. So what you can see here, M1, that is mass of the dry steam that is entering here with the dryness fraction X1. M2, that is a mass of water collected, that is here is M2. This is M2. Okay, this is M2 value. X, that we have to find out. So what is X value? That is M1. This is M1 X1, that is M1 X1, that is mass with dryness fraction X1 enter into the throttling calorimeter, divide by M1 and M2, M1 plus M2. This is M2. Here what we will get is a M1. Here what we will get is a M1. So this M1 plus M2, that is the total mass of the steam entering from here, and X is the value of dryness fraction. So what are the advantage? It can measure the dryness fraction even for very wet steam. It give very accurate result, and that is most effective to measure the steam that is entering into the turbine from the boiler. So I hope the working of this separating and throttling calorimeter combination is very much clear to you. How to find out the dryness fraction X, that is also clear to you. Now we try to solve one numerical based on that. So in the numerical, what is mentioned, the mass of the dry steam leaving the separating calorimeter is a 1 kg. Mass of the water separated in the separating calorimeter is 0.1 kg. Pressure before throttling is 10 bar. Pressure after throttling is 1 bar. The temperature after throttling is 120. We have to find out what is the actual value of dryness fraction X. So here you can see during the throttling process the pressure is dropping. correct? The mass of the steam leaving the separating calorimeter, that is entering into the throttling calorimeter, that is 1 kg, and the mass of water which is collected in the separating calorimeter is 0.1 kg. So first what we have to do, we have to use the steam table and we have to find out different required properties at P1, that is 10 bar, that is before throttling and after throttling. So let us understand how to read the steam table and how to take the properties. So यहाँ पे स्टीम टेबल को कैसे यूज़ करना है दिखाया है. So for P2 1 bar, so this is a 1 bar. So at 1 bar the saturation temperature is mentioned here. You can see the saturation temperature, that is 99.62, that is 100 bar. HF value. So HF value will extend, you can see here this is a line for 1 bar. Now we want to see what is HF value, that is enthalpy of saturated liquid, that is 417.4. Here it is taken 417.5. For different property table this value may slight vary. Here Hg value, here for this steam table HFG is available, but in this case we have directly available Hg, that is 2675 kilojoule per kilogram, that is 2674.5 kilojoule per kilogram. So for this P2 pressure we are having saturation temperature, enthalpy of saturated liquid and enthalpy of saturated vapor. This is available with us, plus Cp we have to remember, that is 2.1 kilojoule per kilogram Kelvin. So now that is available. Now the second pressure is 10 bar. So now what we have to do, we have to go for the 10 bar, that is the last line. Again I am drawing one line so I can tell you. Okay, so now at 10 bar, what is the temperature, saturation temperature? 179.9. Okay. What is HF value? HF value, that is enthalpy of saturated liquid, 762.8. So here it is mentioned 762.6. HFG is directly mentioned 2015.3. So what we have to do, we have to go for Hg minus Hf, that is 2778 minus 762.8. So almost it is 2016.2 or that value is available. So here we have to go for Hg minus Hf, that is this value minus this value, and this answer will come. So what you can see is at 10 bar pressure we are having HF value, HFG value, or you can say we have Hg value. So now you can easily read the steam table, you can take the values, and now we have to put all these values in the data. So what you can see, at 1 bar saturation temperature is available, HF is available, HFG is available, from that Hg is available, Cp is known to us. So we can calculate what is the H2. Okay, that is enthalpy of the steam after throttling device, that is Hg plus Cp into superheat temperature minus saturation temperature. So Hg is known to us, that is this value. Cp of steam 2.1, this temperature is given 120, saturation temperature is 100, that is known to us from the steam table. So we will get enthalpy of the steam after throttling device is 2716.5 kilojoule per kilogram. You try to calculate by your own, use the calculator. Enthalpy before throttling, that again we have to find out, that is at 10 bar We know what is the HF, we know what is the HFG. So we can find out X1, that is H2 minus HF divided by HFG. So H2, that is 2716, HF is known to us 762, and HFG, that is 2015. So all these three values are placed here, and we will get what is the X1 value. So what is the dryness fraction of the steam after separating calorimeter? That is 0.969, means steam is having dryness fraction 0.969 is entering into the throttling calorimeter. So now we have to do the exercise for the throttling calorimeter. So actual dryness fraction X, that is M1 into X1, that is mass enter into the throttling calorimeter, dryness fraction of the throttling calorimeter, divided by this is mass collected in the separating calorimeter, mass collected in the throttling calorimeter. So what you can see, that is 1 into 0.969 divided by 1 plus 0.1. So what is the X value? That is actual value of dryness fraction at which the steam is entering from steam मेन स्टीम पाइपलाइन में से सेपरेटिंग एंड थ्रोटलिंग कैलोरीमीटर में जो स्टीम आ रही है उसका ड्राइनेस फ्रैक्शन है 0.881. इट मीन्स दैट the original steam is 88.1% dry and it contain 11.9% moisture. So friend, this is a very important numerical. If you want, you can go one or twice through this numerical. If you are very much clear about the numerical, definitely you can solve any numerical which is asked either in your class test, in your end sem examination, or in any competitive test. And also we had discussed how to read the steam table also. So thank you very much to see this video. Do not forget to subscribe this channel, like this video and share this channel as well as video with your friends. Again, the channel name is AVM Tech Android and this is a QR code for the channel. Thank you.